Alright, so which of the following set of number contain all the factors of 6? Factors are numbers that can divide equally into another number without leaving a remainder. So 1 is a factor of our number, and a number is a factor of itself. So the only other two will be 2 times 3, right? So 2 and 3, those are factors. Let me tell you, say very similar to PEP. Alright, which of the following statement is true? Both 23 and 29 are prime numbers. That is true. We can look on the other options still. Both 23 and 29 are not prime numbers. That is a lie. 23 is a prime number, but 29 is not. That is a lie. And 29 is a prime number? No. So A would be the correct one. All right, let's move on to 3. Solve 6 to the third power. All right, solve 6 to the third power. So when we say once a number is raised to the power, it's the number multiplied by itself that number of times. That means we should multiply it by itself 3 times 6, 6, 36, and 36 times 6 equal 216. Should not be interpreted as 6 trees, but 6 to the third power. What's the square root of 100? Report that one. All right. So what's the square root of 100? Square root means what number multiplied by itself give you this number, which is 100, right? So 10 times 10 give you 100. So it's 10. All right. Number 5. What is 160,000 written in standard form? All right, standard form mean it must be between 0 and 10, right? So you can put the zeros in here. All right, so you put the decimal point here, so you're going to carry it right here. So you just count the number of decimal places it takes to reach there. 1, 2, 3, 4, 5. So the answer would be 1.6 times 10 to the number of places so we'll move, which is 5. Should have been positive because we're going to the right. The original decimal point is located to the right, so we'll go to the right box. So when we multiply 1.6 times 10 to the 5, we'll get back that product here. So that's C. Good job, guys. Good job. Everybody get that, I think, yeah. What is 2.3 times 10 to the third power? 2.3 times 10 to the third power. Alright, so 2.3 times 10 to the third power. We can rewrite this as 2.3 times 10 to the third power. 10 to the third power is 10 times 10 times 10, right? That means it's 1,000. So all we're doing is moving the decimal point this number of times to the right. So we are moving 3 places to the right. So you can just add a couple zeros. 1, 2. So we need another move. 3. So that's 2,300. Two person send me. Yeah, Davian, that is it. Just somebody else had sent me while I was presenting. Let me just check it out. And then we'll move on to 7. 7 is always a problem. Yeah. Correct, Jaden. All right, so we can move on to 7. Yeah, man, always. And a day in England, as I said, guys, this is a British exam, so you always refer to England at times. On one day in England, the temperature outside was -5 degrees. The temperature inside the house was 20 degrees. What was the difference in temperatures? Have fun with that one here. Alright, so one day in England, the temperature is 5 degrees. Alright, so basically, how temperature work when it's below zero, them times are freezing point, right? So zero that come like the boy at the equator. So above, this is the warm temperature. So let's say this is 20 degrees. And then down here now, we have cool. So this is about 5, yeah. So that's why they have the minus, because this is cool. So this is 5, -5. Now, what they want is a difference in temperature. So let's say we wanted to, how can we get from -5 to +20? First, we'd have to go up 5, right? And then another 20. So it's 5 plus 20. It's not about no minus, nothing or nothing, right? That's the difference in temperature. Look on it that way here. Suppose it was 30 degrees and one was 25 degrees. And we say, what's the difference? The difference would be 5 degrees, right? But not it going a positive or a negative because they are both the same. But remember, you know, those coolness represent the negative. Once it's below zero, they start representing negative. So answer D. All right. Let's move on to number 8. Those who are here a long time should be able to do number 8 without guessing it. What
Excuse me, sir.
written as a binary number? Yeah, man, go ahead.
Sir, you put a negative sign beside the equals. When you I got the answer for number 7, it was -25, and you said the answer was D.
Yeah, I'm still saying it's D, you know.
How, sir?
I just explained, right? It's a difference in temperature. Now, below zero, you have the negative. That's how the negative come in, because it's really cold. Consider below zero as cold. So that's why they have the negative. Freezing point, right? And then now above, you have warmer temperature. Zero go up. So they want the difference in temperature. If you're at -5 degrees, how will you get to +20? To be 25, right?
Yeah.
As I say, people always struggle to understand, but it's not that hard, man. I think because they have the negative in front of it, it's not saying like don't look at it as a negative, just look at it as cold temperature. So it represent like, give me a chance, guys. Let me look at number 8.
Okay, sir.
Mm-hmm.
Well, sir, I won't be able to do number 8 since I never learned it yet.
Yeah, some people have though.
Okay.
Yeah.
Where's your pencil? On the chair, on the phone.
So I didn't learn it either.
Your pencil.
Okay. All right. So a few persons have not done it ever, but this is how simple it is. So what we're gonna be doing is, basically this is like the language a computer understand, 1 and 0, right? So let's go. So all we're doing is dividing 13 by 2. Now what happened? You see the remainder, that's gonna be our answer. So all you say 2 into 13, how many groups of 2 you can get out of 13? That is 6, and that will remainder 1. And you continue again. 2 into 6 goes 3 times, but this time the remainder is 0. And then it's a 2 into 3, 1 time, but the remainder is 1. And how you read the answer? Oh, by the way, when you reach 1, you stop. Okay, now go into point, right? Like 2 into 1 is 0.5. So you read the answer this direction up. So it will be 1101 base 2. They don't put the 2 there, but yeah, so it's actually C. And guys, just to say something as well. To get back the 13, this is how we get back the 13. Because this is base 2. Let me space it out so you guys can see. What we do, we start 2 to the 0, 2 to the 1, 2 to the 3rd, and 2 to the 4th. Right? 2 to the 0, that's 1. Everybody should know that any number raised to the power 0 is 1. So we multiply 1 times 1, this is 1. 2 to the 1 is 2. 2 times 0, 0. So we put plus 0. What is 2 to the 3rd power? 2 times 2 times 2. What about 8? 8 times 1, 8. Now, man, something right. Somebody said they understand now. All right. Something often. 2 to the square, 2 to 6. 2 to the 0, 2 to... Oh, this should be 2 to the 2. Yeah, something go wrong. So yeah, your account, right? So these are 2 to the 2, which is 4. As I'm saying, how come the numbers are big already? And then 2 to the 3rd is 8. So I'll add these 8 plus 4 plus 1 to get back the 13. You can learn it in IT, guys. Alright, let's look at number 9. Solve 1 minus 0.32 plus 0.08 plus 0.4. What's the answer for that? Alright, solve 1 minus 0.32 plus 0. We could even add them here first, right? So the rule for decimal, when we're adding and subtracting, decimal point must be placed on the decimal point. So we could add them here. So 8 and 2 over 10 plus the 0. So 0 carry 1. And then of course we have 4 and 3, 7 and 1, 8. So this is 0.8. And we are subtracted from 1. So that would leave 0.2, right? Remember guys, this is 1 whole. Alright, so see you guys on Sunday. Somebody remind me to start at number 10, alright? Take care guys, keep safe. Hope the others return soon. Bye entity, take care. Oh, the bonnet. This one again.
Bye, sir.
Bye
Bye,
Israel,
sir.
bye Jeremiah, take care.
Yes,
See you
sir.
guys soon, alright?
Yes, sir.
Yeah. Big up. Hope the others can join us back soon.